Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you're doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to calculate LCM and GCF of more than two numbers. In fact, by the end of this video, you will be able to solve these examples. I have already taught you how to calculate LCM and GCF of two numbers, and it would be great if you watch those videos first. I'm going to put the link in the descriptions. But more importantly, I expect you to know how to write prime factors of a number. I'm going to put the link of that video in the description as well, because the method that we are going to use for calculating LCM and GCF is prime factorization. Okay, let's start with GCF. For calculating GCF, first we must write prime factors of all the numbers. Then GCF will be equal to common factor between all of the terms with the minimum power. I know that it could be a little bit complicated for you, so don't worry about this formula. You are going to learn that through examples. So do not worry about this formula if you do not get it. Look at the first example. We want to calculate GCF of three numbers. 120, 72, 32. We have two methods. The first one is factor listing and the other one is prime factorization. We are going to use prime factorization. Why? Because factor listing is going to take time, and of course the possibility of making mistake is really high. So let's start with 120. As you can see, I have 0 at the end. When I have 0, I can write at the end, I can write 2 and 5. Then I'm able to drop the 0. I'm going to have 12. Okay, do I know any prime number that I can divide 12 by that? Yes, 2. If I divide 12 by 2, the answer will be 6. If I divide 6 by 2, which is a prime number, the answer will be 3. And I can divide 3 by 3, the answer will be 1. When I reach 1, I must stop the process. On the other hand, I have 72. Do you know any prime number that I can divide 72 to that? Of course, it is 2. The answer will be 36. I can divide it by 2. The answer will be 18. I can divide it by 2. The answer will be 9. I can divide it by 3. I'm going to have 3. Divide by 3. 1. I must stop here. And I have 32. I can divide it by 2. 16. Divide by 2. 8. Divide by 2. 4. Divide by 2. 2. And divide by 2. 1. When I reach 1, I must stop the process. Okay, let's start with 120, which is the first term. So, as you can see, I can write 120 as I have 3 2's. So, 2 to the power of 3 times I have 1 5, as you can see, times 5, and I have 1 3, as you can see, times 3. I can write 72 as you can see, I have 3 2's, so 2 to the power of 3 times 3 to the power of 2. I have 3 to the power of 2 here. And I can write 32 as you can see, I have 5 2's here. 2 to the power of 5. Now I want to calculate GCF. Let's see which factor is common between all of them. Look, in the first one I have 5. In the second one I do not have 5. In the third one I do not have 5. So 5 is not common between all of them. In the first one I have 3. In the second one I have 3 as well. But in the last one I do not have 3. So a factor to be considered must be common between all of them. So I should not consider 3 because one of the terms does not have 3. But 2 is common between all of them, as you can see. So I must consider 2 with the minimum power. What is the minimum power of 2 between all of these? Look, the power of 2 here is 5, here is 3, and here is 3. Of course, the least power is 3 here. So GCF will be equal to 8 for these numbers. Look at the next example. Here we have 4 numbers, as you can see. Let's start with the first one and write prime factors of 24. Do you know any prime number that I can divide 24 to that? Of course, 2. The answer will be 12. Do you know any prime number? Yes, 2. The answer 6. Yes, 2. 3. 3. 1. When I reach 1, I must stop. I have 15. Of course, I can divide it by 3. The answer will be 5. I can divide it by 5. I reach 1 and I must stop. I have 12. So I can divide it by 2, 6, 2, 3, 3, 1. And also I have 18 here. So I can divide it by 2. The answer will be 9. Again, I'm telling you, if you don't know how to write prime factors of a number, I strongly suggest you to watch that video first. I'm going to put the link in the description. I can divide it by 3, 3, divided by 3, 1. So first term, which is 24, I can write it as you can see, I have 3 2's and 1 3. So 2 to the power of 3 times 3. And I can write 15. Let me separate this part. And I can write 15 as 3 times 5. And the power of both of them are 1. I can write 12 as, look, I have 2 2's and 1 3. 2 to the power of 2 times 3. And I can write 18 as, you can see I have 1 2 and 2 3's. So 2 times 3 to the power of 2. So GCF will be equal to common factor. Can you please tell me which common factors do I have? Let's start with 2. In the first one, I have 2. In the second one, I do not have 2. So if I do not have one term, one factor in one term, I should not consider that. So because I do not have 2 in the second term, I should not consider 2. I have 2 in 3 terms, but I must have this factor in all of the terms. So I will not consider 2. What about 3? I have 3 here, 3 here, 3 here, and 3 here. So I have 3 in all of them. So I must consider 3. Okay, what is the power of 3 here? The power of 3 will be minimum of all the powers. The power of 3 here is 1, here is 1, here is 1, and in the last one is 2. So minimum between all of them will be 1. So 3 to the power of 1. What about 5? Should I consider 5? No, because I have 5 only in the second term and I do not have it in all of them. So GCF will be equal to 3. Let's calculate LCM. For calculating LCM, we are going to follow the same method, which is writing prime factors of a number, and then we are going to multiply common prime factor with maximum power by uncommon prime factor with their main power. I know that at the beginning it can be a little bit challenging and complicated, so don't worry about it. We are going to learn that through example, exactly like GCF. We have 3 numbers. First one, second one, and the last one. And we want to calculate LCM of these 3 numbers. So again, we are going to write prime factors of these 3 numbers. I can divide it by 2, 12, 2, 6, 2, 3, 3, 1. I must stop here. I have 15. So 3, 5, 5, 1. I must stop here. And I have 12. I have 2, 6, 2, 3, 3, 1 here. I must stop. So as you can see, I can write 24. So as you can see, I can write 24 as 2 to the power of 3 times 3. So 2 to the power of 3 times 3. What about 15? As you can see, I can write it as 3 times 5. And for 12, I can write it as 2 to the power of 2 times 3. So LCM will be equal to, first, let's specify which terms are common between all of them. Look, the only term which is common between all of them is 3. So we are going to write 3 and we must consider the maximum power. What is the maximum power of 3 between all of these 3 terms? Here is 1, here is 1, here is 1 as well. So the power of 3 will be 1. What is the next term? I have 2 in both of the terms. Should I consider that because it's not common between all of them? Some students usually do not consider that and tell me, teacher, you told us not consider if it is not common between all of them. Yes, it was for GCF, not LCM. When we have LCM, if it is common between some of them, you must consider that. So I must write 2 with which power? 2 or 3 with the maximum power. So maximum power will be 3 and I have 5. Should I write that? Yes, of course, I must multiply 2 on common prime factor. With which power? With its own power. The power here is 1, so here is going to be 1 as well. So LCM will be equal to 8 times 15, which is 120. Let's solve next example with each other. Here we have 4 terms and we are going to follow exactly the same method. So I can start with 24. We did 24 several times. I can divide it by 2. The answer will be 12. I can divide it by 2. The answer will be 6. I can divide it by 2. The answer will be 3, 3, 1. Let's write for 30. Because we have 0 at the end, I can write 2 and 5. Then I can drop the 0 and I can divide it by 3. I have 1. I have 36. I believe that we did 36 earlier. I can divide it by 2. 18, 2, 9, 3, 3, 3, 1. And of course we have 14. Because we have a 0 at the end, I can write 2 and 5. Then I can drop the 0. 4. I can divide it by 2. 2. I can divide it by 2. 1. So let's write these numbers. In the right side, let's start with 24. I can write 24 as 2 to the power of 3 times 3. So 2 to the power of 3 times 3. And I can write 30 as 2 times 5 times 3. And I can write 36 as 2 to the power of 2 times 3 to the power of 2. 2 to the power of 2 times 3 to the power of 2. And I can write 40 as 2 to the power of 3 times 5. Okay, now I want to calculate LCM between all of these terms. Can you first please tell me factors that are common between all of them? Yes, as you can see, in all of them I have 2. Okay, so I must consider 2 with which power? With the maximum power. Here the power of 2 is 3, 1, 2, 3. So which power should I consider? Maximum one, which is 3. And I must multiply this. Look, here I have 3, 3, 3, but in the last one I do not have 3. Should I consider that? Yes, because I'm calculating LCM. So I'm going to write 3 with which power? With the maximum one. Maximum power of 3 is 2. I'm going to write the rest at the bottom times. Should I consider 5? Yes, I have 5 here and I have 5 here. It is common between 2 of them, but because I'm calculating LCM, I must write it with which power? With maximum one. The maximum power of 5 is 1. Let me erase the board to write the rest. Okay, I'm going to write the rest in the left side. So LCM, as you just saw, is equal to 2 to the power of 3 times 3 to the power of 2 times 5, which is, it's going to be 8 times 9 times 5, which is equal to 360. And this is the correct answer of this example. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write them in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.